Okay, so we are on to part 2. I hope you had some success with those 2 problems that I had you work on before you watch this video, okay? So now what we're going to do is look at some other problems. So this is problem number 3 that we've done so far. So we're going to look at something like 2 times x raised to the 3/4 power equals 16. All right, so in this case, we don't have a radical. And we'll be able to get to a rounded form in a little bit, but when we have an exponent, we can still focus on isolating the x. So we think of like our directions here that I gave you beforehand, isolating the radical. We're not going to isolate the radical. What we're going to do is we're going to get the x and the exponent isolated now. So we're going to take that 2. Remember, this means 2 times x to the 3/4. So we're going to divide by 2 to get rid of that 2. We're going to get x to the 3/4 power and then divide here to get 8. Okay. So from here, now we need to get rid of this exponent. Well, in order to get rid of something, we do the inverse or the opposite of something. So when we look at the inverse of 3/4, it's actually the reciprocal. So we're going to take the reciprocal. Instead of 3/4, we're going to raise it to the 4/3 power. And remember that whatever we do to one side, we have to do to the other to keep it balanced. Okay, so what happens is these exponents cancel out. So now we're just left with an x, and we have 8 raised to the 4/3 power. Okay, well, remember that we learned that we can easily change something like this with a fractional exponent into a rad. So we can do power over our root. So the root is 3, and then we have a power of 4. So the cube root of 8 is 2. And then we have to raise it to the 4th power. So x equals 2 times 2, which is 4, times another 4. It's going to give us 16. So x equals 16. Okay, so anytime you have, you don't have a radical and you only have an exponent is when you're going to do something like this. And I think this might be on one of your homework page tonight. So there you go. I just did a homework problem for you. All right, and then the next thing we're going to look at is problems like this. We have the square root of x plus 1 equals x minus 1. So we're going to do 2 problems like this. All right, let me move it over. So we'll worry about 5 in a second. Let's focus on number 4. All right, so notice that we've got one radical. Our goal is to isolate the radical, which we already have here. Our radical is already isolated. So now we're going to square both sides. Well, when we square this side, we have a radical and something squared. So these kind of cancel each other out, which leaves us with just x plus 1. But this is not x squared and another 1 and 1 makes negative 1 or a positive 1 or something like that. This means 2 of all of these. So you need to remember that that is multiplying 2 binomials, okay? So you can either do FOIL or box method to multiply these back together. You should be experts at that right now. And so I'm going to go ahead and do FOIL. X times x is x squared. Then I'm going to get a negative 1x and another negative 1x. 1 times 1 is a positive 1. So I end up with x squared minus 2x plus 1 on the right, but I still have this x plus 1 on the left. Now remember, we're solving, and right now I see a quadratic so far right here. So let's move these over. We can't solve using quadratic formula or factoring until we get it set equal to 0. So now we're going to subtract 1. At the same time, I'm going to subtract x and put it right by what we have here. So x squared, I add these together, I get negative 3x. Add these together, oh, I get 0. So actually, this is what I get. I get a quadratic of x squared minus 3x. So when I have a quadratic, I have two choices. I could factor, I could do quadratic formula. When I'm looking at this problem, I see that there is a GCF of x, and then I'll end up with x minus 3. Well, that's easy to solve. I've got x equals 0. There we go, I'm done. And x minus 3 equals 0. And when I add 3, I get x equals 3. Let me move this up so you can see it. There we go. All right, and then the last thing we do have to do is check for our extraneous solutions. So if I plugged in 0, I'm going to go all the way up to my original problem here, and I'm going to use this little space up here. So I'm going to do 0 plus 1. So I'm putting 0 in all of the x values, and then I'm going to get 0 plus 1 equals 0 minus 1. Okay, so let's see, square root of this and this becomes 1. So 0 minus, I get 1, square root of 1. Uh-oh, and then I'm going to get a negative 1. So if I look here, if I have 0 plus 1 is 1. 0 minus 1 is going to give me a negative 1. But when I get this, it does not work. These are not congruent. These are not the same. So therefore, this 0 is not a solution. It didn't work because I plugged it back into my original. 0 plus 1 is 1. 0 minus 1 is negative 1, and that's not consistent, okay? So now we're going to try 3. So let's see what 3 does. So 3 plus 1, square root of that, equals 3 minus 1. Okay, so now we're going to get 4, square root of 4, equals 2. 2 equals 2. There we go. That one works. So for my answer for this one, I would not write the 0. I would only write 3. So be very careful and make sure that you check for your extraneous solution.